Okay, the following is a video over 2.3, which is techniques for computing limits. This is the algebraic method, algebraic. And so this is what you would do if you didn't have a graph. Okay, so we're still doing the same thing, finding y values given certain x values. So, but the first method that we want to talk about is direct substitution. This is what you do first. Okay, given a question like this, you plug in the x value into the function and see what you get. Okay, and so let's go ahead and do that. So the limit value here, if I were to write this, I'm just going to write -2 times 1 plus 5. Okay, now notice that I didn't write limit. Okay, that's because I plugged in x. I plugged in 1 for x. Once I do that substitution, I don't need to write the limit anymore. I'm just evaluating this. And so this gives me -2 plus 5, which gives me 3. All right? And so the limit, as x approaches 1, of -2x plus 5 is equal to 3. Okay? So let's take a look at another one. All right? The limit as t approaches -2. So let's just plug in -2, see what we get. Okay, so -2 quantity squared plus 5 times -2 plus 7 is going to give me 4 plus -10 plus 7. So this gives me 4 plus -10 is -6, so -6 plus 7. And then this is just going to give me 1. Okay, so we get values, all right? That's what we're going to do. So on number 28, the limit as t approaches 3 of the cube root of t squared minus 10. So let's do that. We're going to get the cube root of 3 squared minus 10, which is going to give me the cube root of 9 minus 10, which is going to be the cube root of -1. And the cube root of -1 is -1. Okay, -1 times -1 is 1 times -1 is -1. Okay. All right, let's try number 32. All right, so this, we got 3 divided by the square root of 16 plus 3 times 0. Okay, and then plus 4. All right, so we get 3 all over the square root. Okay, 16. Okay, 3 times 0 is 0, so we just get square root of 16 plus 4. And so then we get 3 divided by the square root, 3 divided by 4. 3 divided by 4 plus 4, which gives us 3/8. Okay, so that's the limit value for number 32. All right, so that's what we try first. If we do that and we get numbers, we're good. Okay, let's skip down to number 40. These are limits that are indeterminate. Okay, which means we can't determine them. So we try direct substitution first. Okay, we just try and we plug in 3, so we get 3 squared minus 2 times 3 minus 3 all over 3 minus 3. Okay, and so we get this. We get 9 minus 6 minus 3 over 3 minus 3. Okay, so 9 minus 6 is 3. Minus 3 again gives me 0. And then 3 minus 3 also gives me 0. Okay, folks, we can't do this. We can't determine what this value is. Okay, this is indeterminate. We can't divide by 0. If we had 0 over some number, okay, this would be fine, but it's indeterminate, okay, because we are dividing by 0. So we got to think about something else that we can do. We got to do some algebra here. Okay, now when I look at this numerator here, I see that it's a quadratic, and I think that we can factor that. So I'm going to write the limit as x approaches 3 of, okay, what does this factor to? All right, I've got what two numbers add to -2 and multiply to -3? So it's going to be 1 and 3, so I get x plus 1, and then I get x minus 3. Okay, and I'm going to divide this by x minus 3. Okay, and when I see this, all right, I see that my x minus 3's and my x minus 3's can divide out. Okay, we can simplify this function here. We can operate within this function. And then I'm going to take the limit as x approaches 3 of just x plus 1. Okay, and so when I do that, now I'm just going to, I can plug in 3 into this and get a number. Okay, I'm going to do 3 plus 1, which gives me 4, and that's my limit value. okay? So we want to do some algebra to manipulate this. Okay, now what's actually happening here, when you have two things that divide out, you get a whole. Okay, when that happens, this is where you have a whole, like in all those other previous examples that I've given you with wholes. Okay, all right, so now let's try 46. All right, let's see what happens with that. Now I'm just going to go ahead and plug in 0, and so I end up getting 1 over 5 plus 0 minus 1/5 all over 0. Okay, now guys, I already noticed that I'm dividing by 0 here. Okay, this is indeterminate. All right, indeterminate. Indeterminate. Look. Okay, so we got to do some manipulation here. Okay, see what we can do algebraically to simplify this. Okay, and so here's what I notice. Right off the bat, I notice that I've got fractions within fractions. Okay, I got a fraction here, I got a fraction here, and then I have one big fraction. Okay, I've got what I call these are incepted fractions. Okay, fractions within fractions. So let me write this out. Let me get some space here. The limit as h approaches 0 of 1 over 5 plus h minus 1/5 all over h. Okay. Now, when I have incepted fractions like this, I want to turn this into one fraction. Okay. So let's put our numerator as one fraction. Now, to do that, we got to get a common denominator. So I'm going to multiply this by 5 over 5. I'm going to multiply this fraction here by 5 plus h over 5 plus h. Okay. And then I'm going to get this as my limit. Okay. So I'm going to get the limit as h approaches 0 of 5 over 5 times 5 plus h minus 5 plus h over 5 times 5 plus h. Okay. Now what I've got here, guys, is I've got two fractions in my numerator with a common denominator. I can write this now as one fraction, but before I do that, I need to make sure to realize that I'm subtracting a quantity here. Okay, I got to put parentheses around this because I'm going to have to distribute a negative. All right, so make sure you catch that. All right, if you're dividing by something or subtracting by something like this, you want to make sure that you put parentheses around a quantity. All right, so now, all right, I've got the limit as h approaches 0 of 5 minus, okay, I'm going to distribute my negative here, so 5 minus 5 minus h, okay, all over 5 times 5 plus h, okay, one fraction in my numerator, all divided by h, okay, so I've got this fraction up here, actually that looks like an h, okay, and that's just part of one big fraction. So if I'm dividing by h, okay, that's the same thing as multiplying by the reciprocal. This is the big step here, folks. This is where I got screwed up, okay, growing up when I was your age. All right, so the limit as h approaches 0, and I'm going to do this. The top part, 5 minus 5, that reduces down or cancels out to 0. So I end up just getting negative h divided by 5 times 5 plus h times 1 over h. Okay, so dividing by h, folks, is the same thing as multiplying by its reciprocal, 1 over h. All right, and then look what happens here, guys, is my h's divide out to 1. Okay, so now I have this. I have the limit as h approaches 0 of negative 1 over 5 times 5 plus h. Okay, now, because I divided that h out, I'm going to go ahead and plug in 0, okay? And I get negative 1 over 5 times 5 plus 0, which ends up just giving me negative 1 over 5 times 5. 5 plus 0 is just 5, which is 25, and that's my limit value, okay? So now, here's one thing I want you to notice here, okay? That's a lot of stuff that we just did. Feel free to go back and pause and rework this. But notice, guys, that in each one of these steps, I haven't taken the limit yet. Okay, I keep writing this, equals limit as h approaches 0, equals limit as h approaches 0. I do that in every single step until I actually plug in 0. Okay, that's when I take the limit. All right, and then I can get a number. And that's what I'm looking for. We got to get a number. All right. Guys, I really hope you enjoyed this. This is a lot of stuff, but this is good stuff. I really had fun.